Okay, so in one of my previous videos, I had discussed about the idea of hypothesis testing. And in that video, I had discussed what is the logic behind doing a test of hypothesis. And we had also looked at what kind of steps are involved in hypothesis testing. So in this video, what we are going to do is we are going to take an example and try and do a test of hypothesis using this example. So let's consider a situation that a person is having a coin. Okay, he is having a coin in his pocket. He takes out that coin and flips it 6 times. Okay, and in the 6 trials, he gets the following outcomes: heads, 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 tails, and heads. All right. Now, you see that out of these 6 trials, the result is 5 times heads, and on one occasion, you have got tails. Now, seeing 5 heads in 6 trials could actually raise a suspicion with regards to the fairness of the coin. On one hand, if you are skeptical, you may say that, look, after all, 5 heads in 6 trials is very much likely. It can happen by chance. So there is nothing unusual about this coin, and it can always happen. So therefore, I would still go ahead and believe that this coin is fair, and this extreme observation is just a chance event. All right, so there's nothing unusual about the coin, meaning you believe that the coin is fair. And what does that mean? It means that if you were to toss this coin again, then you still believe that the probability of getting heads in the subsequent toss is going to be half. On the other hand, if you are kind of looking for some unusual situations, you may say that, hey, look, out of 6 coin tosses, 5 are heads, meaning there is something wrong in this coin. I think this coin is biased towards heads. Okay, so that is the other belief that you may have. So therefore, this is a situation where you need to do a hypothesis testing. Okay, so let's go ahead and do that. The dilemma here is that whether the coin is fair or the coin is unfair. So let's see how we can go about doing this hypothesis testing. So the very first step that we have to do is we have to first put down what are our hypotheses. So first we are going to put down our null hypothesis, which is coin is fair, and to write the same thing in mathematical language, it would be written as the probability of getting heads for this coin is 0.5. All right. Now, what is the alternative hypothesis? The alternative hypothesis is that the coin is unfair. And in mathematical language, this would be written as P of H is not equal to 0.5. Note, it is not equal to 0.5, meaning all we are interested to know, or rather we are interested to go by either one of these hypotheses. Either you think that the coin is fair, or you may at the end of the day conclude that the coin is unfair. Okay, but you are not interested as of now to find out that if the coin is unfair, whether it is fair towards, or rather, whether it is biased towards heads or whether it is biased towards tails. That is not something that you want to figure out right now. All you want to do is to go by either one of these hypotheses, that the coin is fair or the coin is unfair. All right. So we have completed the first step. The second step that we have to consider is, let us set our significance level. Let's say we are going to work at 5% level of significance. Okay, meaning our threshold cutoff p-value is going to be p less than 0.05. Okay, fine. What is the third step? In the third step, what we are going to do is we are going to assume that the null hypothesis, meaning H0, is true. Meaning you go ahead and assume that the coin is fair, meaning the probability of heads in the next flip is still going to be 0.5 for heads and 0.5 for tails. And then ask the question, what is the probability of getting this observation or equally or more extreme observation than this. This meaning the one that you have got as of now. Okay. So let us find out what kind of extreme observations we have to consider. Well, in this case, you had 5 heads and 1 tails. The other equally extreme observation, if the coin could be biased towards tail, is it could have 1 heads and 5 tails. And there are 2 other more extreme observations than that, which is all 6 are heads with no tails and all 6 being tails with 0 heads, 6 tails. So we have these 5 extreme observations which can be possible. Equally or more extreme observations than the one that you have got. Okay, 5 heads, 1 tail, 1 heads, 5 tails, 6 heads, 0 tails, and 0 heads and 6 tails. Okay, fine. So these, we have to compute the probability of these outcomes. Okay, right? So there are 5 trials. What is the probability of getting 5 heads and 1 tails? Well, we have to simply follow the binomial probability distribution. So the probability of this observation will be, let's say heads is success and tails is a failure. And here we are going to assume that the coin is fair. So the probability of getting this observation is 6 choose 5 times probability of heads, which is success, half raised to the power 5 times probability of tails, which is again half raised to the power 1. Okay. Now, what is the probability of getting 1 heads and 5 tails? Again, 6 choose 1 times probability of heads raised to the power 1 times probability of tails raised to the power 5. Note that we are considering both probability of heads and tails to be half each because we are assuming here that the coin is fair. All right. What is the probability of getting 6 heads and 0 tails? So we say 6 choose 6 raised to the power half, half raised to the power 6 times half raised to the power 0 because there are no tails. And what is the probability of getting 0 heads and 6 tails? Well, that is 6 choose 0 times probability of heads raised to the power 0 times probability of tails raised to the power 6. Okay, fine. So let us now see what is the total probability of an extreme event like this or more extreme than that, considering that the coin is fair. And in order to compute that probability, we have to add up the individual probabilities of all of these 4 things happening. All right. So the probability of getting this observation or an equally or more extreme observation than that is the summation of all these probabilities. So let's quickly write what these are. So this will turn out to be half raised to the power 6. You can try it out yourselves. Plus this one again, 6 choose 1 is again, this will be 6. This one will be 6 times half raised to the power 6. This one is 6 choose 1, which is again 6. And these two will give me half raised to the power 6 again. Plus 6 choose 6 is 1. And these two give me half raised to the power 6. Plus 6 choose 0 is also 1. And these two again give me times half raised to the power 6. All right. So if you do the calculation, you will see that the value for this addition turns out to be 0.2187. All right. Okay, here you are. The addition of all these values will yield you the probability of this event happening or an equally or more extreme event happening than that is 0.2187. Right, so what is the next step? Step number 4. Here you ask, what is the probability that you have got? The probability that you have got is 0.2187. What is your threshold probability with which you are working? Your level of significance that you have decided is 5%, meaning if the probability is less than 0.05, then you would reject the null hypothesis. But your observation or equally or more extreme observation than that, the probability of that happening is 0.2187, which is not less than 0.05. And so in that case, you basically say that if the null hypothesis is true, because that's where we all started, then you say that the probability is 0.2187. The probability of me getting the observation under consideration or an equally or more extreme observation than that is 0.2187. And that probability is not so low that I will say that there has to be some underlying reason, which is why I got 5 heads and 1 tails. I will say that there is no sufficient evidence to state that there is anything wrong with this coin. And so because this probability value is not less than 0.05, and so therefore what you do is you go ahead and accept the null hypothesis, which is that the coin is fair. So this is what you go by.